So I got this problem sent in. This is 13.2, problem number 1. And the first part the student is fine on because it's a lot like the section 13.1, where you're just performing the one-way ANOVA test to see if these means of the different samples are close enough together so that we're pretty sure that they all have the same mean. Okay. But in this section, in section 13.2, we want some additional information. If they aren't all exactly the same, which one is kind of different than the others, or which two are different than the others? They might all three be totally different means, or let's say 1 and 3 might be similar, but the mean for sample 2 is totally different. So we start the same way that we started in the previous chapter. We do ANOVA one way. We grab, we want to compare these 3 different samples. But what's different is we do compute 2-key test. Okay. And this is where the student got the p-value for the first part right here. This is just the same as in chapter 13.1. Since the p-value is so low, the student rejected the null hypothesis. So we know at least one of these things is kind of different from the others. Now, the 2-key test will give us the ability to kind of figure out which one is different than the others. So we create confidence intervals for the difference, right? Now remember, if they are significantly different, the confidence interval, right, will not contain 0, because 0 is when there's really no difference between the means. Like if 2 numbers that aren't very different, you subtract them and you get really close to 0. Okay, so if the confidence interval doesn't contain 0, then those 2 means are pretty different. Now the first one we're entering in is mean of sample 2 minus mean of sample 1. And this is mean of sample 2 subtracted from sample 1. Okay, and we want to do 2 places. So that's negative 11.1. And this is 6.04. This is mean 3 subtracted from mean 1. So that is, the lower bound is 2.48. And the upper bound is 19.62. And then here's where we have mean 3 subtracted from sample 2. Right, mean 3 from sample 2. That is 5.01 is the lower bound, and 22.15 for the upper bound. So those are those 3 confidence intervals. Okay. Now we have to analyze what this means. Now think about this real quick. The difference between mean 2 and mean 1, the confidence interval definitely contains 0, right? So we're saying that we have a 95% confidence that 0 is in this interval, that there's no difference between these 2. Whereas there's a 95% confidence that 0 is not in the difference between mean 3 and mean 1. That would say that there's a significant chance that the sample for mean 3 and mean 1 aren't the same, right? And same thing here. Mean 3 is significantly different than mean 2. So what that tells us is it's really mean 3 that's not. Mean 1 and 2 have a significant chance of being the same, right? But mean 3 is definitely different than either of the other 2. So we select this one, where mean 1 is equal to mean 2, but what this is really saying is not equal to mean 3, is that it's not equal to mean 2 or mean 1. Okay? Oh. There's one more part. The box plots. This, I'm running out of time in the video, but you can do this real easy by just going graph, box plot, sample 1, sample 2, sample 3, and then just have them drawn horizontally. And then hit compute, and it should give you the graphs. And you can choose, I think it's this one right here, if I had to guess real fast.